So in this lecture we will be studying the module number 5, which is on transport layer. So the first part is responsibilities or duties of the transport layer. The data link layer performs a node-to-node delivery. The network layer provides host-to-host packet delivery using datagrams. So we saw the data link layer is providing a node-to-node delivery and the transport layer is providing a host-to-host packet delivery. It delivers the data packets using the datagrams. The transport layer builds on the network layer to provide data transport from a process on a source machine to a process on a destination machine. So it will transport the data from a process on the source machine to a process on a destination machine. Real communication takes place between two processes, so transport layer performs process to process delivery. Process to process communication. The main duty of a transport layer protocol is to provide process to process communication. So what is the main duty of a transport layer protocol? To provide a process to process communication. That is, it will provide a communication between the process on the source machine to the process on a destination machine. To define the process, we need port numbers. So there are port numbers and the port number will define the processor. So using that port number, the source machine will be identifying the destination machine, that which destination it has to send the or transport. Okay, so from process, so it is providing a process to process communication. And how is a process defined? Using the port numbers. Encapsulation and decapsulation. To send a message from one process to another, the transport layer protocol encapsulates and decapsulates messages. So to send a message from one process to another process, what the transport layer protocol does, it encapsulates and decapsulates messages. Encapsulation happens at the sender side. So it happens at the source machine, you can say. Encapsulation is happening at the source machine, that is at the sender side. Decapsulation happens at the receiver side, that is it happens at the destination machine. Decapsulation happens at the destination machine. So decapsulation happens at the receiver's site. Next is multiplexing and demultiplexing. The TL at the source, that is a transport layer at the source, performs multiplexing, collecting messages from server processes for transmission. The transport layer at the destination performs demultiplexing, delivering messages to different processes. So at the source machine, again what happens? Multiplexing. Multiplexing is happening at the source machine or at the sender side, whereas demultiplexing happens at the destination machine, or you can say at the receiver's site. Next is what? Relatability using flow control. Flow control balances the exchange of data items between a producer and a consumer. At the transport layer, we use buffers to hold data packets when the consumer is not ready to accept them. Relatability using error control. Relatability at the transport layer can be achieved by adding error control. It includes detection of corrupted packets, resending lost and corrupted packets, discarding duplicate packets, and reordering packets that arrived out of order. So what are packets? Packets are nothing but the data packets are nothing but you have some kind of information in them. So which errors are controlled? Detection of corrupted packets. If there are any corrupted packets, then it will be controlled. resending lost and corrupted packets, discarding duplicate packets, the ones which are duplicators. So duplicate packets will be discarded. 2 copies have been formed, we say it is duplication. And reordering packets that arrived out of order. So the packets in whichever order they are sent, they are received also in that order. So if they are not received in that order, then what it will do, it will reorder the packets that arrived out of order. Congestion control. A transport layer can provide 2 types of congestion control, open loop and closed loop. In an open loop congestion control, the protocol tries to avoid the congestion. In a closed loop congestion control, the protocol tries to detect and remove the congestion after it has occurred. So in open loop, it will try to avoid the congestion. In closed loop, it will try to detect and then remove the congestion after it has occurred. Types of services. In a connectionless service, the sender sends packet to the receiver without any connection established. So there is no connection established between the sender and the receiver, and the packet is sent. In a connection oriented service, the client and the server first need to establish a connection between themselves. The data exchange can only happen after the connection establishment. After data exchange, the connection needs to be released. So after the data packet has been exchanged, what will happen? Connection will be released, that is, it will be removed. So first what happens? A connection is established between the client and the server. After the data packet is sent, what will happen? This connection will be broken, or you can say it will be released. So connection is released after the data packet has been sent. So this was all about the responsibilities or duties of the transport layer.